In this question, we have to determine the value of the resistance such that the current passing through the network will be I of t is equal to 8t into e to the power of minus 2t. Okay, there are several methods through which we can do this problem. One which I am going to the method which I am going to use here is the simplest and the smallest of all the approaches. Okay, whatever be the kind of question that you come across, in a problem involving a series or parallel RLC circuit, it is always suggested, or the best method would be to find the poles of the solution. That is, first to find the values of S, and then from the values of S you can say what kind of response the system would exhibit. For instance, if the values of S are real and negative, then it is a overdamped case. Okay, if it is complex with real negative part, then it is underdamped. So like that. The case which is given here is critically damped case, which means S will be having equal and negative real values. So that happens when we have alpha is equal to omega naught. Okay, where alpha is 1 by time constant, okay, and omega naught is the natural frequency of oscillation. Now the value of alpha will be 1 by 2 RC for parallel RLC circuit. Its value will be R by 2L for series RLC. Okay. Now the value of omega naught will be 1 by root LC for both the cases. Now the circuit which is given here, since it is a series RLC, we will get alpha is equal to R by 2L. So this should be equal to 1 by root LC. So R is equal to 2L by root LC is equal to 2 of root L by C is equal to, so the values that are given here is L equal to 1 and C equal to 0.25. 2 by root of 0.25 is equal to 2 by 0.5 is equal to 4. So the value of R is equal to 4 ohms. It is also noteworthy that if we see the system response, the value of I, here we can see e to the power of minus 2, which means that the time constant is equal to 1 by 2. Again, the time constant is equal to 1 by alpha. Now we get alpha is equal to 2. From that also we can determine the value of R.